Hey everybody, it's Miss Moran and I'm here to talk to you this week about multiplying a fraction by a whole number. We're going to be extending what we learned in our last unit on adding fractions, and we're going to relate that to what it means to multiply, where multiplication is really just repeated addition. We're also going to be using some concepts from earlier in the year talking about multiples. We learned about multiples and factors. All right, so first we're going to start with unit fractions, which is a concept we learned in our last unit on adding fractions. So for unit fraction, we're taking the 1/8 size piece and we would be decomposing 6/8 into 6 1/8 size pieces. So we learned in our last unit that we could make 6/8 is the same as 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. 1, 2, 3, 4, 5, 6. So 6 1/8 pieces is 6/8. Well, we've also learned since 3rd grade that multiplication is just a quicker and more efficient means of doing repeated addition when you have the same size piece. So instead of doing 1/8 over and over and over 6 times, we're going to learn in this unit that we can treat this as a multiplication. We can do that as 6 times 1/8. So we're going to start with that concept with a unit fraction. And then we're eventually going to extend that into fractions that don't just have a unit fraction. Now, we could also look at this 6/8 and say, well, the way to decompose or to break down 6/8 is not only to do 1/8 piece 6 times, but there are other ways I could do that also. I could say 2 times 3/8 would also be 6/8, which would really be the same as 3/8 plus 3/8. That's what 2 times 3/8 means. So doing 3/8 twice. And then of course we could also do that, flip those factors around, thinking like commutative property we've already learned about. We could also do that as 3 times 2/8, which is the same as 2/8 plus 2/8 plus 2/8. 2, 4, 6. So 6/8, whether we use a unit fraction or whether we use a multiplier of some other fraction of eighths. Which brings me into our next concept, which is multiples of a fraction. So we learned about multiples back in our very first unit when we did multiples and factors. So multiples are what you get when you multiply. So we're going to think about, can we list multiples of a fraction? Can we list the skip counts of something like 3/5? So what that means is if I started with 3/5 and I had one of them, I would have 3/5. If I repeated that or multiplied that again, I would have 3/5 twice. We learned in our last unit that we're going to work with the numerators and leave our denominators the same, because those denominators just tell us the size of the piece. So 2 3/5 pieces would be 6/5. 3 3/5 pieces would be 9/5. 4 3/5 pieces, 3, 6, 9, 12, would be 12/5. And 5 3/5 pieces would be 15/5. And this could continue on as long as we wanted to multiply. So one thing we'll notice here is that our denominators are not changing. These are all just the size of the piece, and those remain consistent. What does change is our numerator, and all of these become a multiple of 3. 3, 6, 9, 12, 15. So we would look at what numbers could be multiples of 3/5, what numbers could not be multiples. So 24/5 could be a multiple of 3/5 because I could multiply 8 times of 3/5 to equal 24. Something like 25/5 would not be a multiple because there's no way I'm going to multiply 3 or skip count 3's and end up with 25. Here's another example, 2/6. We're going to hopefully get students to think repeated addition without having to actually write that out. So we don't want to have to do 2/6 plus 2/6 plus 2/6 plus 2/6. We want them to understand our 6 pieces stay the same, and this becomes a multiple of the number I'm starting with. So 2/6, 4/6, 6/6, 8/6, 10/6, 12/6, and so on. Now I notice that a lot of these, actually most of them, because when you multiply, numbers get a whole lot bigger than when you just add. These numbers end up being fractions greater than 1. So it's going to be okay for us to leave those as fractions greater than 1 in this unit. At times it might ask for us to also make it a mixed number, and we can, but it's okay for us to leave these like that for now. All right, so then we're going to get into, can we just understand what it means to multiply a fraction by a whole number? None of the fractions we're going to be multiplying in this unit are going to involve fraction by fraction. They're all going to be fractions by whole numbers. So 1/4 times 6, what is the meaning of that? That could mean 1/4 piece, and we're going to do a little bit with models on this, but we could take a 1/4 piece and draw 1/4 6 times. We'd count up how many shaded pieces we have. I think instead of drawing out on that model 6 times, it's much more efficient to think about it as 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4. Now the thing about fourth graders is they don't like to do a whole lot of writing. They don't like to do a whole lot of extra work. So they very quickly understand this, and a lot of them did in the last unit with addition. They were already starting to understand multiplication concepts. So instead of having to do this over and over and over, it's a whole lot easier to just multiply. Well, what do we multiply here? What do we multiply? What we don't multiply? Same as we did when it came to adding fractions. We're going to work on the numerator because that tells us how many pieces we have. 1, 2, 3, 4, 5, 6 of them. We're not going to do anything with these denominators other than make sure they stay the same because they just tell us the size of the piece. So instead of writing all that out, we want students to get to the point where they understand I'm going to be multiplying, but I'm only multiplying my numerator. Denominator is going to stay the same. So 6 times 1 is 6 and 6/4. All right, so 3/8 times 4. That's 3/8 plus 3/8 plus 3/8 plus 3/8. Or I can say my denominator is going to stay as 8. 4 times 3 is 12. We can make that 12/8. Or we can take care of our fraction greater than 1 and put that as a mixed number. 8/8 is 1 whole, and that's 4 extra eighth pieces. Some students are even ready to do this into a simplest form, 1 and 1/2. Okay, so any of these would be acceptable answers, and it kind of depends on the question that's being asked, which one we'd want to use. All right, and so we'll look at one more fraction here. I've already come up with the product, and we're going to look at decomposing a fraction like 8/10. So what are several ways we can multiply to make 8/10? Well, we could multiply the unit fraction 8 times 1/10. So that'd be a 1/10 piece 8 times. So what are other ways we can multiply to make 8? What are the factors of 8? I could also do 2. Okay, 2 times what would give me 8? 2 times 4. That's the same as saying 2 4/10 pieces. So that's 4/10 plus 4/10 equals 8/10. Okay, we could also say, flip that around, commutative property. I could do 4 times 2/10. So 2/10 plus 2/10 plus 2/10 plus 2/10. 2, 4, 6, 8. So again, we're getting, hopefully after the first couple days, we're getting away from repeated addition and saying it's a whole lot easier to say 8 times 1, 4 times 2, 2 times 4. And then of course I could do also 1 times 8/10 itself. All right, so that's going to be multiplying a fraction by a whole number. And then towards the end of this unit, we're going to take it to a little bit larger numbers. And then we're going to be doing multiplying mixed numbers. And there's 2 strategies that we're going to use here. So I'll start with the one that I prefer because I think it lends itself to the fewest number of errors. So first, what does this mean? Again, we're going to relate it to our unit on adding because once we say that multiplication is really just repeated addition, it makes it a whole lot easier for kids to just intuitively know what to do. So what does this mean? This means 1 and 2/8 3 times. So 1 and 2/8 plus 1 and 2/8 plus 1 and 2/8. And when you write it out like this, students are going to automatically understand and remember, oh, okay, we're going to have to multiply, or we're going to have to do our whole numbers and our fractions. 1, 2, 3, 3 wholes, and this is 2, 4, 6, 3 and 6/8. If we don't get them to understand that multiplication is repeated addition, then here's the mistake they're going to make. When we learned about adding fractions, we learned we got to do the whole numbers with the whole numbers and the fractions with the fractions. So a lot of kids will say, all right, I'm just going to do my whole numbers times themselves, and then my fraction I'll leave alone. So a common mistake would be to say 1 times 3 is 3, and then we just have a 2/8, so we'll just make it 2/8. Okay, and that's not what we want to show. Also, if you were to draw this out as a model, 1 whole and 2/8, we're going to do this 3 times. Okay, so this is 1 whole. Sorry, I should have run something better I could color here with. So 1 and 2/8, 1 and 2/8, 1 and 2/8. This lends itself to students seeing they need to do what we call the distributive property, which is multiplying by both of these parts. I need to do 3 of my wholes. I also need to do 3 of this fraction, not just wholes and fractions completely separate. But as soon as you get them to understand that it's a repeated addition, they do it correctly, and they don't do that. All right, so after we get that foundation, then we'll say now we can just go straight to multiplying here. And understanding 2 times 2 and 2/5 is the same as, 2 and 2/5 times 3 is the same as multiplying the whole number 3 times and the fraction 3 times. So 2 times 3 is 6. Denominator stays the same as 5. And 3 times 2 is 6. Okay. Now this is a fraction greater than 1 we don't want to leave, because we don't want to have mixed numbers and fractions greater than 1 in the same problem. So in our last unit we learned that we can take this 5/5 is a whole, so this is 1 piece extra over the whole. So a better way to say that is 7 wholes and 1/5. All right, so that is my favorite way to multiply the mixed numbers. I'm going to show 2 different strategies here for the same problem. This is another one that is possible and is presented. I don't prefer it because I feel like it has more steps than necessary and more opportunities to make mistakes. But it is an option for students who want to try it that way. And that is to make this not be a mixed number, make it a fraction greater than 1, and then just multiply. So I know 3 1/3 is the same as how many total third pieces? Well, 3 wholes of 3/3 is 9, and 1 more is 10. So I can make it 10/3 times 5. Okay, so we just said we're going to leave our denominator the same and multiply this. Okay, the problem comes in is that now I need to fix this back to a mixed number because my problem was presented as a mixed number. I want to get my answer that way too. So now you're getting into students have to be able to divide. 50 divided by 3, that's a little bit more work. Not impossible, but then you're having to go back into, can I do long division if that's not something I can skip count my way through. Okay, so 3 goes into 50. If I do 3 times 10, would be 30. That leaves me with 20 left over. 3 times 6 is 18. That leaves me with 2 left over. So I'm getting 16 with a remainder of 2 out of 3. All right, now again, I'm going to do the exact same problem the way that I prefer, and then you can see that they both end up to be the same answer, and I think this one's just a little bit simpler. So this is 3 times 5 is 15, and then 5 times 1 is 5/3. Okay, this is a fraction greater than 1 with a mixed number, so I want to get rid of that. 3/3 is a whole, so this is 2 pieces over the whole. I'm going to bump this up to 1 whole more and make it 16 and 2/3. Okay, to me a whole lot simpler than doing all of this, but this is a method that is presented. It is a method that some students would intuitively try to do on their own or figure out, so either one of those are acceptable. It just kind of depends on how big the numbers are. Kind of with smaller numbers a little bit better. If you start to get really large numbers here, you probably don't want to be messing with a fraction greater than 1 with too large of a numerator. All right, well, thank you for taking time to watch, and those are all the skills that we're going to do for multiplying fractions and mixed numbers. That'll take us through a pretty short time, a little less than 2 weeks. And again, no multiplying fractions by fractions in 4th grade. That'll be a 5th grade skill. All right, thank you.